So welcome again. As we continue learning networking commands and also tips and tricks of using our laptop and also how to make money online. Today I want us to go through traceroute command in details. But before that, remember on this channel, I'm also showing you various ways you can make money blogging, YouTube, TikTok, and our social media accounts and micro jobs. Be sure to check our playlist section. And if at the end you find this video helpful, remember to hit like button and also subscribe to the channel. So today let's run traceroute command in details. In the previous tutorial I just did a walkover together with an example of how it is used. Today I want to explain in details. It traces the route your data packets take to the destination and back, so you can be able to tell. So when troubleshooting network issues or analyzing performance of the connection, traceroute command is one of the most valuable tools you can use. Short form, Tracert. It helps network administrators, IT professionals, and any other user to identify network bottlenecks. Let's say you're trying to access the internet, and when you try to Google, you're not able to open a certain site. When you ping, you realize ping commands are dropping. This is where traceroute comes in. It helps you identify where the issue is, which hop or which router has the issue. So what traceroute command is, it's a diagnostic tool available on most of the operating systems. It could be Windows, Mac OS, and Linux. It traces the route data packets take from the source, which is your computer or your laptop, or if you're doing traceroute from your router or access point to the destination IP address or domain name. That is the server that hosts the domain or the website or whatever service you are trying to access. It shows each hop, which is a step, every step the packet takes along the network path, revealing IP addresses of the routers along the way and the time it takes to reach them. So from where you are, there is a router inside. So you have your access point, then you have your router. From your router, it goes to ISP router. From ISP, now it navigates across until it reaches the destination. So traceroute works by sending Internet Control Message Protocol (ICPM) echo request messages like we saw with ping, with an increasing time to arrive (TTL) value to the destination. TTL, which is time to arrive, represents the maximum number of hops a packet can make before being discarded. And as the traceroute increments this value for TTL, it allows the packets to travel one hop at a time, revealing the intermediate routers and devices it passes through. Why is then traceroute useful? We saw why ping is useful. So today let's see why traceroute command is essential. 1. Diagnosing slow connections. So by observing the response time from each hop, you can identify which specific router or network segment is causing latency. Let's say you have some networks within your network which have some routers in between. So you can tell from that router to your another router to your main router to ISP to destination which router have an issue. You can be able now to troubleshoot even further and know where the issue is. It also helps in identifying the network bottlenecks. Slow and delayed response from one or more hops in the trace can indicate network congestion or an underperforming router. So let's say it's your router and you realize there is a slow response from it. You can tell whether there is congestion, network congestion. That is, maybe there is overutilization of the bandwidth that is allocated to you. which can tell maybe somebody is trying to download, or there is a service that is overutilizing your network, which you can always tell from other commands, and you can be able to tell which computer or laptop or network device is initiating that network congestion, or a router which is underperforming, maybe outdated software, or maybe it's an old router which may need replacement, or even maintenance. Traceroute also helps in locating routing issues. If a packet doesn't reach its destination, Traceroute can reveal where the route fails, helping you troubleshoot routing problems. Remember, the issue is not. Remember, the issue can be even on your ISP. If you don't know how to use Traceroute, then you may not be able to identify these, and you may waste a lot of time trying to resolve the issue internally while it could be outside. So Traceroute goes router by router. Where there is an issue, you may find that route fails, and you can tell that is the route. That is the router which has a problem. And working together with your ISP, you can be able to resolve that. It's also used for monitoring network performance, to provide insights into the health of your network, helping you monitor status of network devices along the path. So if you can be able to tell each device and the response time, it can help you now monitor performance of those devices, and even recommend which device should be changed. So Traceroute and ping are very useful commands which help you in troubleshooting your network. Then how do you use Traceroute command? On Windows, you open command prompt using Windows button R. You type CMD, then you press enter, the black window. On Linux, you open terminal, and also on Mac OS, so you just open terminal application. So let's see how we can learn Traceroute. So you write trace RT, then space the destination. It could be google.com or an IP address. Your DNS server will translate this domain into an IP. Remember, routers know each other through IP address, and even servers and all the network devices, they know each other through IP address. So once it is translated, your router will be able now to route that traffic to that IP. And as you notice, it is translated to this IP address. So google.com translates to this IP. And you can see now the hops or the steps. It starts from my laptop to my router. This is my router. Then to my ISP router. Then goes to other routers in between until it reaches Google's destination, google.com. So let's wait, and as you can see, there is time that is reported, which will come and explain in details. So it displays hops the packet takes and time it takes to reach each hop. So let's interpret these results or the output of a Traceroute. So when you run Traceroute command, the output displays several key items. One of them is hop number. These numbers 1 to 7. Those are the routers it has taken to reach Google from where I am. So the hop number, this is the order in which the packet reaches the router or network device. The first hop is usually your router. As I said, this is my router. So the first hop is router. If there is a delay in this time, then there is an issue between your laptop and your router. If time then is higher, it means there is an issue with your router because it is the one which is returning that response. The second one is usually maybe your ISP if there is no other router in between. So you can always tell. So if like now on hop 3, you can see the time was higher. There could be some issue with that router, but again, remember the other people who are also sending their request. Then there is the IP address. this IP address you can see here at the end. Some has the domain, the subdomains. The IP address of each router or device the packet encounters is also displayed. So these are IP addresses where that packet have passed, which helps identify where packet is traveling. You can always tell now if you Google these are public IPs, you can tell the specific companies. I don't want to go into that. You can check with yours. You just copy one IP address, just paste. It will give you the details of that router. Who owns that router? It could be another ISP. It also gives you round trip time, RTT. Round trip time in milliseconds. As you can see, this time is in milliseconds. It is the time it takes for a packet to go to each router and back. So this time here is the time taken by my packet to move from my laptop to my router and back. Then the second one from my router to ISP router and back, like that. So it is the time the packet takes to go to each router and back. Traceroute typically shows 3 different measures. As you can see, we have 3 time entries. So different measurements per hop, representing 3 attempts to send packets. So the first attempt to send, it returned 2 milliseconds. Second attempt, 1 millisecond. Third attempt, less than. So if you notice the time is increasing, then there is a problem, like the last one. But it should not go above 200 milliseconds. If time is reducing, then it means the response time is higher. So as you can see, my traceroute, that is the output, which I've explained in details. So hop 1, that is number 1, that is my router, my local router, which takes less than 2 seconds. It's 2 seconds or less to respond. Then hop 2 is the second hop, shows the response time between 2 milliseconds and 5 milliseconds, indicating the packet that have traveled to my ISP. This is my ISP. So from my router to ISP's router. Then the third hop is now the time is increasing, 121 to 19 milliseconds. So this is a backbone that is closer to your destination. These are backbone routers, maybe beyond my ISP. All these are backbone. Then the last one, which is the final hop, as you can see, between 9 milliseconds and 129, it is the time it takes to reach Google server. So this is the Google server. 3, 4, 5, 6 are called backbone routers. Number 2 is my ISP. Number 1 is my local router. Number 7 is Google's server. So I hope that explains. So the output will continue until packet reaches destination, or a maximum hop of or the maximum number of hops, which is usually 30 if it is reached. So it will terminate. And that may happen if there is an issue in between. Then how do we use traceroute to identify network bottleneck? One of the most common uses of traceroute command is to diagnose network bottlenecks. If you notice that one particular hop consistently shows high latency, that is high number than other hops, it might be the cause of network congestion. You can tell with the number 3 and number 7. There I would expect, because I'm not the only one accessing Google right now. So this is especially useful when diagnosing through internet. So you can always use a traceroute to tell whether your internet is slow. I wish I could do this when I have many people in the office who are using the internet. You can tell Like now you see to my ISP, it looks like I'm the only one in the office. That's why that time is less. Number one and number two. But beyond that, I'm not the only one accessing Google within our locality or even outside our country. That is for the backbone routers. From number 3 all the way down, you notice time also increases. So the issue on number 3 and number 7 could be either congestion. As I said, I'm not the only one accessing Google server beyond my ISP, because my ISP is also serving other people. It could also be a reason where maybe they have an underperforming router or a faulty network device at that point, which is beyond me. If that persists for some time, then I can always report it by either contacting my ISP or even try to check my internet speed. So then how do you diagnose slow connections? If your connection feels slow, Tracert can help you pinpoint where latency is introduced by checking on the RTT time. That is round trip time. If you check number 1 and 2, now for the second Tracert command, number 1 and 2 they have low latency below 3 seconds. But after that, we experience hops exhibiting high latency, but not that high as such, but anything above 100, that's high. The issue is likely even further down, which then points beyond even our ISP. That is backbone routers. They could be having other issues, but remember, from my ISP, there are also other ISPs which connect to these backbone routers. Another useful aspect of Tracert is identifying network routing loops, where a packet continually circles through the same router without reaching destination. You notice maybe when I do Tracert, it still reports within the same IP. The next hop, instead of reporting 192 at hop 5, it is still reporting the 72.14. Then it continues for some time. That's what is called routing loop, where the same router keeps on retrying the same packet without reaching the destination. If Tracert fails to return to the destination, or if certain hop has asterisks, stars, instead of IP addresses and time it is stars, or there is time then stars, which indicates no response, it could suggest a routing issue or misconfiguration at that point. If it is your router, then you need to check it. If it is your ISP, you just call them. If it is beyond ISP, you just either wait or even report to them, then they can check with whoever they are pointing to after their router. It also helps troubleshooting routing problems. Tracert is also helpful when there is a routing problem, such as if you cannot reach a particular website or a service. Let's say you're trying to access Google and you can't access. There could be a routing issue. How does that work? There are companies which host their website out, or web services, or even mobile apps outside, which consume maybe a web service. And maybe you are not able to reach it. Then using Tracert, you can be able to know whether it is a routing problem. So suppose you are trying to access a website like google.com, but it is unreachable. Running Tracert to the site can provide valuable insight into whether the issue lies within your local network, your ISP, or somewhere along global internet backbone. So after your ISP, now those are backbone, they are the one called internet backbone or backbone routers, which route then traffic to the site you are trying to access. As noted, using ping command can tell you you're not able to reach a certain site. Now with Tracert, it can even point the exact point where there is an issue. So let's say I'm trying to access google.com over maybe a maximum of 30 hops. Then on hop 2, instead of returning the entry 311 then IP for my ISP, it returns XXX then request timeout. Then after some time it returns hope 3 now with the timer. Then hope 2, since it is showing request timeout, it suggests there is an issue with my local router, firewall, or ISP is either maybe blocking ISPM request. So you may need to even troubleshoot further. That's where now other commands comes in. So after your router, if you are not able to reach your ISP, the issue is at your router. And remember, the router, as I said during ping, it has two interfaces. It has the internal interface, inner interface, and outer interface, which is your outside interface. Outside interface has your public IP. Inner interface has your local IP. The local IP is the IP you get first for your router. If you are not able to go past that, that is, your ISP is not able to return any IP, it means there is an issue with now that router, your local router. And you only need to check your router configuration, or you check whether you have a firewall and a router, physical firewall, physical router. You check which one has an issue. If firewall is built in your router, then you need to log in and confirm you have not changed any rules and any settings. And you can troubleshoot further now to know whether the issue is the firewall itself. We'll see other commands which can help you do that. So now, let's take an example of how you can use Tracert. You are trying to watch internet, maybe YouTube video, and you have a slow internet. Then how do you point where the issue is? You run a Tracert to youtube.com. Let's try that. youtube.com. So you are tracing route to youtube.com. Notice there is a small lag. I got on my ISP. It goes to the next backbone router, but notice there is a high latency after within my backbone routers. So it will go all the way to YouTube. So let's now explain these. In hope 4 and 6, you notice there is high latency than the other hopes, indicating the issue may be further down the router, which is true. Remember, all these, they are going to Google server. As you notice, the IPs, they point to where Google is hosted. YouTube is also a Google platform. And there are many people using. So that means bandwidth. There is overutilization of bandwidth beyond my ISP, which is beyond me. And if you wanted to troubleshoot further, you can always complain to your ISP, who will then check the next router. Why is it so? But again, as I explained, beyond my ISP, there are also other ISPs which are also routing traffic from other people. So that is expected. But if the latency is very high, then there is an issue beyond that. So in conclusion, trace command is an essential tool for troubleshooting and diagnosing network issues. By tracing the route that data packet takes from your computer to destination, you can be able to identify where delays, bottlenecks, and routing problem occurs. Whether you're dealing with a slow internet or a specific network device issue or general performance problem, you can use Tracert to get valuable insights that can help you now resolve the challenges you're experiencing. So understanding how to interpret the output of Tracert goes a long way in maintaining and troubleshooting your network and ensuring smooth connectivity and faster performance. Remember, if you combine this with ping command and other commands that I'll show you still in this channel, you can troubleshoot and run any network. Remember, if you're running these and you also run ping command alongside these, remember you can open several command modes on your laptop, like this running Tracert, and another one learning ping. This one how to run ping. Then you can learn them side by side. And you monitor both. Ping will tell you whether you're able to reach YouTube. Let's try ping youtube.com. Then we run a continuous ping. As that runs, you can always also run Tracert to YouTube on this other one. And you can compare even the response time. So from ping, it tells you you're able to connect to YouTube and the response time. From Tracert, it tells you the route your packet takes to reach YouTube and whether there is any bottleneck. And if you found this video helpful, remember to hit the like button and also subscribe to this channel. I'm also training how to make money with blogger.com and AdSense, and all steps I've taken to get approved, and also AdStera, and also other ways you can make money with social media. Remember to check playlist section, and let's meet in the next one. Thank you so much.